Hey boys and girls, today we are going to go over our density nodes. For those of you that remember our physical and chemical changes, we're actually zooming in on one of our physical properties a little bit more, which is density. When we talk about density, we're basically going through and discussing the idea of mass, and when we think about which of these two objects has the greater mass, we've got a kilogram of feathers or a kilogram of rocks. And hopefully you've by this point figured out that a kilogram of feathers and a kilogram of rocks has the exact same mass. Of course, the next question we'd ask if we're thinking about density is which has a greater volume. And we would assume that the greater volume would likely be for the feathers because they're going to take up more space. Well, the idea of density is going through and comparing our numbers when we come to mass and volume together. So realistically, looking at the definition of density, density is going to be defined as a mass per unit of volume. So if we're getting all sciencey, that's going to be our definition. But if we want to talk a little more literally, density is just going to be how tightly packed the molecules are. Okay? The more tightly packed they are, the more dense they are. The less tightly packed they are, the less dense the object is going to be. So density is basically considered the amount of matter in a given area or a given volume. So knowing that density is the mass per unit of volume, if we were to take different objects that happen to have the same volume and yet have different weights or different masses, we could go through and figure out the density of those objects. So if we took a 1 centimeter cubed block of wood that happens to have a mass of 0.5 grams, a 1 centimeter cubed block of water that would have a mass of 1 gram, or a 1 centimeter cubed block of iron that would have a mass of 8 grams, which of those would likely have the greatest density? I hate to even say likely. Which of those would have the greatest density? That would be our iron, because we have the most mass for the same volume. Okay. So which of these is most dense? Iron, and it has the most mass for that given volume. And proof that water and ice have different densities basically is the ice or the water more dense. In this case, we can compare densities of different objects based on which one will rise above the other. Objects that happen to be less dense, in this case, objects that happen to be less dense are going to stay on top of objects that happen to be more dense. The more dense you are, the further you're going to sink down. And once we get further into class, we'll go through and watch some videos and do some demos about comparing hot versus cold liquids to see if the different densities, or if densities change at different temperatures. So we'll look at that a little bit more in class. But we know that all different objects have different densities. Our baseline for density is, in this class, going to be considered distilled water, and it has a density of 1 gram per centimeter cubed. Knowing that, if an object happens to have a greater density than that, is it going to sink or float? Well, something that's going to have a greater density means that the molecules are more tightly packed, and that means it's going to sink compared to the distilled water. Okay? So objects with more than 1 gram per centimeter of density are going to sink. So your examples there would be stuff like gold, your lead, your aluminum. Those objects would all sink because they have a greater density than distilled water. On the other hand, if you happen to have less density than 1 gram per centimeter cubed, the object is going to float. And your example there is going to be ice, or we could go through and look at wood, with this specific example being oak, or we go through and think about air. Obviously air stays above water and it's considered floating, or we go through and think about ethanol. All of those objects will float in distilled water. Now, is water going to be the only object that we could use to compare it to? No. You could go through and you could try to compare gasoline to vegetable oil. You could compare mercury and iron. Mercury, being a liquid, happens to be very, very dense, and therefore even dense objects can float on mercury. And a big idea here is that it does not matter how much of a substance you have, is that that object is going to have the same density. And what I'm trying to say here is 1 gram of gold is going to have the exact same density as 100 grams of gold. It does not matter how much of the gold I have, because as I increase the mass, the volume is going to proportionally increase as well. So your density is always going to stay the same. And as we saw last slide, that means that our gold is always going to have a density of 19.3 grams per centimeter cubed. Okay? And we looked at the idea in a little bit of different objects having different densities. Well, you can actually compare multiple objects at once. The least dense is always going to stay on the top, with the most dense falling to the bottom, and you'll see stratification at every level based on the density. So in this case, which of these, and take a second to think, which of these objects is going to be the most dense? You should have come up with the idea that honey is going to end up being the most. And which of these is going to be the least dense? Vegetable oil. Vegetable will be the least. Okay, and so in terms from most to least, you'd have the honey, and then the corn syrup would be second most dense, and then dish soap would be third most dense, and our obviously red water, water with food coloring, would be the second least, and then vegetable oil would be the least. And you notice how there is a nice stratification. There is a very, very distinct line at each of these levels between the different densities. And again, we could go through and find some chart in a textbook or reference manual somewhere that would tell us the exact densities of each of those objects. Okay, so we went through and talked about the least dense, we talked about the most dense. Now, how do we determine density? We're going to do this in class a whole bunch of times. I'm actually going to run a lab on it too. Step 1, you need to find the mass, and in this class we're going to do it using the triple beam, which you guys should be used to using at this point. The second step, we need to determine the volume. Now we've got 2 ways of determining volume. One is by measuring with a ruler or string or whatever you're going to use, because sometimes with cylinders and with spheres getting measurements is a little crazy. And if we get an object that happens to be very irregularly shaped, instead of measuring, which can get very complicated, we would go through and we could measure by calculating displacement. And displacement is basically how much liquid is moved out of the way when an object is placed into water. And so our picture up top here to the right is showing displacement. We see that the water started at 20 milliliters, and once we added a very irregularly shaped object to the water, it ended up at 23 milliliters. So that means that our displacement was going to end up being 3 milliliters. And that means that our volume in this case was the 3 milliliters. So part 3 of that would be to calculate. And this is something that we haven't gotten into before, but we're going to try to shorten down all of our math into triangles. What we're going to end up doing is, instead of using an equation, and our equation for this would be density equals mass divided by volume, which you see here. Instead of doing that, we're going to go through and we're going to try to set up triangles, and I'm going to get even lazy, and I'm going to use t's, because you notice the triangle is the exact same thing, just without that. Okay. Notice that when we look at this, mass is divided by volume, which means what's going to be our numerator in this case? Mass is up top. And that means the bottom of our triangles is going to end up being volume and density. The reason these triangles are so nice is because if you are given 2 of the objects, the third one is incredibly easy to figure out. If I happen to give you mass and volume, you divide. If I happen to go through and give you mass and density, you divide mass by density. If I happen to give you density and volume, you multiply the 2 together. So it's already set up in an equation for you with mass being on top and the 2 density and volume being next to each other. So it basically shows you what you need to do mathematically to solve for the single unknown. And when we get into this a little more, we should remember our units for mass being grams. We know that our volume is going to be in either milliliters if we're using displacement, or it's going to be centimeters cubed if we're using a ruler. And that means our density units are going to end up being our mass divided by whatever our volume is. And so in the case of the ruler, we've got grams per centimeter cubed. If we're using displacement, it's grams per milliliter. But in either case, grams per centimeter cubed and grams per milliliter are the exact same thing. They're showing the exact same density. And hopefully that makes a little bit of sense. So let's kick our way through a couple quick examples here. Basically, we're going to go through and we're going to calculate the mass of an object that has 35 grams. It takes up 7 centimeters cubed of space, and we need to find the density. So the first thing I want to do is I want to set up my triangle. I've got my density equals mass divided by volume. So let's go through and let's actually plug in stuff. I know my mass is 35 grams. I know my volume takes up 7 centimeters cubed of space, so I know my volume is going to be 7 centimeters cubed, and that means I'm taking my 35 grams and I am dividing by 7, and so my whole thing is going to be 5 grams per centimeter cubed. Okay? And obviously if you want to go through and look at it a little neater, you're going to end up with showing the knowns, showing the formula, what are we looking for, our unknown and density, but we end up getting our answer of 5 grams per centimeter cubed. Pretty straightforward, pretty easy. You bring a calculator class, these should be pretty simple. Right? And again, walking away through some practice problems, we've got density equals mass divided by volume. I am going through and I am taking my mass of, what do I got, 50 grams and a volume of 2.22 centimeters cubed, and I don't even need to bust out a calculator because 50 divided by 2 should be about 25-ish, and that 22.5 looks pretty darn good for me. Okay, obviously a calculator would let us double check, but that should be what our answer is. And again, another practice problem that we'll roll through. In this case, we're going through and we've got density equals mass divided by volume. Density happens to be 1.05 grams per milliliter, and the 575 grams. So in this case we're dividing 575 divided by 1.05, and that should give us somewhere in the 550 range. And I see an answer here, 548. That looks pretty close to my little mental guess, so we'll stick with 548. And remember, because we are looking for volume, our units are just going to be milliliters. So hopefully that seems pretty darn easy. And the final one that we've got, I'll let you guys we'll practice a little more in class. What's the density when we're using displacement? So basically we're going to go through and we've got density equals mass divided by volume. We know that we are looking for density. It's asking what is the density. 48 grams of metal. So I know that this is going to be 48 grams. And the displacement here was from 25 to 33, which means that my volume is going to be 8 milliliters. 48 divided by 8 should give us a nice little 6 grams per centimeter cubed. Again, the units transfer over, so this could equally say 6 grams per milliliter. Same thing. They mean the exact same concept. Okay? And then that's basically a lab that we're going to get into in class either that day or the next day or somewhere in there. Anyways, hopefully density makes a heck of a lot of sense. It should, because it's a pretty easy concept. If you can multiply and if you can divide, the math is easy. It's just a matter of kind of understanding that things that are more dense going to sink, things that are less dense going to float, and we can go through and we compare the densities of any two objects pretty easily. We'll do it again later, boys and girls.